Here I overview the AI4 Good Squared University Project 1.4, Automated Embeddings, Vector Database Population, and Cloud Deployment. AI4 Good Squared, founded by Janssen LLC, is a nonprofit with mission to help humanity prosper. In this video, we provide students with a framework. Students use critical thinking to design and implement part of the process. Building upon the earlier projects, students now transition from learning how to use artificial intelligence to engineering a reusable enterprise AI knowledge infrastructure suitable for production deployment. For Project 1.4, AI4, Good Squared provides a collection of documents. The vector database can include presentations, technical specifications, instructional materials, research papers, content from websites, a microbusiness's complete inventory of informational artifacts and data, and other knowledge assets. The vector database is partitioned to protect the CIA of cybersecurity. They are confidentiality, integrity, and availability. The objective is not content creation, but rather designing and implementing an automated system that securely continuously converts this growing body of knowledge into a searchable AI knowledge base. Every modern large language model, LLM, has an important limitation. It cannot continuously learn from an organization's private information. Instead, enterprise AI systems maintain an external knowledge repository that allows the model to retrieve authoritative information before generating a response. This architecture, known as Retrieval Augmented Generation, RAG, has become the foundation of modern enterprise AI solutions. Students begin by organizing the AI4 Good Squared Knowledge Repository into one or more structured document libraries. These repositories may contain PDF documents, Microsoft Word files, PowerPoint presentations, Markdown documentation, HTML pages, text files, CSV data, JSON, formatted specifications, and other supported formats. Rather than processing these documents manually, students will build an automated ingestion pipeline capable of processing entire directories with minimal human intervention. In one design, ingestion pipeline can begin with LangChain document loaders, which automatically identify and load supported document formats into a common internal representation. Students learn how modern AI systems normalize diverse information sources before additional processing occurs. Once loaded, the documents are intelligently divided into appropriately sized chunks using recursive text splitting techniques. Proper chunking is one of the most important design decisions in retrieval augmented generation, because it directly affects retrieval accuracy, response quality, processing speed, and storage efficiency. Students evaluate chunk sizes and overlap strategies to optimize system performance for enterprise-scale knowledge repositories. Each document chunk is then encoded into a high-dimensional vector embedding using an embedding model compatible with the open-source LLM. These embeddings mathematically represent the semantic meaning of each passage, allowing information to be retrieved by conceptual similarity instead of exact keyword matching. This capability enables AI systems to understand user intent and locate relevant information even when different terminology is used. The generated embeddings, together with rich metadata, are stored. For example, document source, page number, document type, project identifier, author, version, and ingestion timestamp are automatically stored within a vector database, with Qdrant serving as the recommended implementation for Agent OS4 and AI4 ROI Cloud. Students discover how the vector database becomes the long-term organizational memory that enables intelligent retrieval across millions of embedded document fragments. A key objective of Project 1.4 is complete automation. Students design the ingestion pipeline so that new or updated documents can be processed with little or no manual effort. As additional knowledge becomes available, the system automatically loads the files, generates new embeddings, updates the vector database, and maintains synchronization between organizational knowledge and the AI retrieval system. One approach is a user-friendly interface where documents are drag and dropped into a browser window, and the system prompts the user if additional information is needed to process and store each document correctly. After successfully populating the vector database, students validate the implementation by performing semantic retrieval against authentic AI4 Good Squared content. Rather than searching for exact words, the retrieval engine identifies document fragments whose meanings most closely match a user's or AI agent's prompt. Those retrieved passages are then supplied to the large language model, enabling retrieval augmented generation to produce responses that are grounded in authoritative organizational knowledge, instead of relying solely on the model's pre-trained information. The final phase of the project focuses on deployment and portability. Students package the complete ingestion pipeline, configuration files, dependencies, vector database connectivity, and supporting services into a transportable deployment package. The preferred implementation is a Docker container, allowing the entire solution to be deployed consistently across development, testing, and production environments. Students may also evaluate alternative container technologies where appropriate. As an alternative to containerized deployment, students may implement the complete solution directly within the AI4 ROI cloud hosted on Amazon Web Services. This deployment may include cloud-based storage, compute resources, managed vector databases, and supporting AI services, providing students with practical experience deploying enterprise AI systems within a production cloud environment. Throughout the project, students document system architecture, installation procedures, configuration management, testing methodology, deployment instructions, and operational considerations. Emphasis is placed on creating a reusable solution that future AI4, Good Squared student cohorts, and Agent OS for developers can extend without redesigning the underlying architecture. By the completion of University Project 1.4, students will have engineered an enterprise-quality automated knowledge ingestion pipeline capable of transforming organizational documents into searchable vector embeddings, maintaining an up-to-date vector database, and deploying the complete solution either as a portable containerized application or directly within the AI4 ROI cloud infrastructure. They will gain practical experience with the same architectural patterns employed by leading AI organizations to build scalable, maintainable, and production-ready retrieval augmented generation systems. Project 1.4 represents a significant milestone in the AI4 Good Squared curriculum. The resulting vector database becomes the shared knowledge foundation that supports future autonomous AI agents, intelligent assistants, enterprise search, research tools, instructional systems, and AI-powered social media engagement. By combining automated knowledge ingestion with modern cloud deployment practices, students create an enduring AI infrastructure that advances AI4 Good Squared's mission of helping humanity prosper while acquiring highly marketable enterprise AI engineering skills.
Yeah. From the cloud to the village, the mission ignites. AI for Good Square, turning code into light. Students building engines that search through the noise. 16 platforms buzzing, giving small voices a choice. Project 1.1 gets the message out wide. 1.2 brings the brain I was thinking inside. Retrieval guardrails, responses that care, turning noise into connection everywhere. AI for Good Square, impact on the rise. Lifting up Zambia, opening eyes. From off servers to a seamstress and Zams to one smart API. Watch the whole world grow. AI for Good Square up, changing the game. Students leading the future, not playing the same. 1.3 on the cloud, secure, leaning tight. LLM with right, keeping answers right. They don't just code, they question, they weigh. Using AI to build and lead in the way. Critical thinkers winning, not just push and deploy. Human judgment in the loop is the real joy. From classroom to production, the blueprint is set for non-profits to thrive. No one's left in debt. AI for Good Square, impact on the rise. One village, one mission, reaching for the skies. Zamsu sowing futures, AI spreading the spark. Students engineer hope, lighten up the dark. From the cloud to the village, the mission ignites. AI for Good Square, turning code into light. Students building engines that search through the noise. 16 platforms buzzing, giving small voices a choice. Project 1.1 gets the message out wide. 1.2 brings the brain, now it's thinking inside. Retrieval guardrails, responses that care, turning noise into connection everywhere. AI for good squared up, impact on the rise. Lifting up Zambia, opening eyes. From our servers to a seamstress in Zamsu, one smart API, watch the whole world grow. AI for good, squared up, changing the game. Students leading the future, not playing the same. 1.3 on the cloud, secure, lean and tight. LLM with RAG, keeping answers right. They don't just code, they question, they weigh. Using AI to build and leading the way. Critical thinkers winning, not just push and deploy. Human judgment in the loop, that's the real joy. From classroom to production, the blueprint is set for nonprofits to thrive. No one's left in debt. AI for good, squared up, impact on the rise. One village, one mission, reaching for the skies. Zamsu, sowing futures, AI spreading the spark. Students engineer hope, lighting up the dark.